I'll record and I'll decide later if I'm going to put it or not. Y equals 2 times x squared minus 3x. Now, me personally, I probably will multiply the 2 through it, and I'll make it 2x squared minus the 6x. It says find the derivative at x equals to 4. Oh, I'm sorry, no, I'm reading something wrong. Find, part B here, it says find dx dt, notice with respect to t here. When x equals 9, given that dy dt equals 5. That's part B. So I'm going to take this function, this is y here, I'm going to take this one and take the derivative with respect to t, not with respect to x. So this will be 2 times 2, which is what? Here's my first mistake. What's 2 times 2? 4x times the derivative of x, which is dx dt, minus 6, the derivative of x is what? Dx dt with respect to time, right? And the derivative of y is dy dt. I'm taking the derivative with respect to t. And it says find dx dt, that's this one, when x is 9 and dy dt is 5. Let's plug in the values. I can factor dx dt out. I'll have 4x minus 6 equals dy dt. So what's dx dt? Will be dy dt over 4x minus 6. Now let's plug in the numbers. So dx dt, dy dt is what? 5. X is 9. What is 4 times 9? 36 minus 6? 30. 5 over 30, which is what? 1/6. The next one, we're still in the same section. Number 4. This is the radius of a circle. We have a circle. The radius r. The radius of a circle is increasing at the rate of 4 centimeters per minute. That's dr dt. 4 centimeters per minute. Increasing, that's a plus. Find the rate of change in the area. What's dA dt when r equals what? Part A when r equals 10, the other one when r equals 30. I'll just do one of them. It's the same thing. We're looking for the change in the area, so I need to come up with an equation that will tie the area to the radius. And where we have area to radius, is there an equation? That's a circle. What's the area of a circle? Pi r squared. Yep. Now let's take the derivative with respect to time. D dt. of both sides. That would be dA dt. Pi is a constant. 2 times pi times r, but we're not done, times what? dr dt. Plug in the values. It's a question, find dA dt when r equals 10. So I'm looking for this when r equals 10. 10 times 2 is 20. That's 20 pi times dr dt, which is what, 4? That's 80 pi.
10 centimeters.
And this will be centimeters squared per minute, because it's an area. Area is always squared. So I bet you we can write here 80 pi and they'll take it.
Conversion table. Can you bring those two with us as the case to give us the inches again?
Which conversion?
No, I'm saying before. Remember last time they gave us feet and inches? We had to convert it. I can't remember like they.
If we need that, I'll give you that. Yep.
It's like 0.877
Yep.
or something like that. I forget what it is.
If we need to convert, yep. I'm going to put 80 pi there.
They'll take it, Professor.
Except I don't have the submit button.
You had to click the inside box.
Well, I got to answer part B. I don't want to answer part B, so I'll submit. Submit answer. Oh. Oh. Yep, the one I did. They took the 80 pi. And number 5, very similar to number 4, except the shape is different. The radius of a sphere is increasing at the rate dr dt 7 inches per minute. Now a sphere is like a circle but in 3 dimension, like a basketball. This is my attempt to make it 3 dimension. Here we go. So you're looking at 3D there. It goes around like a basketball, a soccer ball, a bowling ball, a golf ball. So the equation for the volume, the question, find the rate of change in the volume. Find dV dt when r equals 9. Then they do it for a different value of r. Again, this one actually, I'll probably give you that on the test. The equation for the volume of a sphere is 4/3 pi r cubed. Again, if you have a book, I know not everyone has a book, but if you get the book and you go to the last page, a sphere, the volume is 4/3 pi r cubed. You could have Googled that too, it would tell you that. 4/3 pi r cubed. Now take the derivative with respect to time. So the derivative of v is going to become what? dv dt. All of this is a constant. Multiplied by 3. The 3 will cancel the 3, that will be what? 4 pi times r squared times the derivative of r, which is what? dr dt. Again, I probably did it too quick there. Here we go, 4/3 pi. What's the derivative r to the third? 3r squared dr dt. And what happens to the 3's? They cancel, and that's the answer I put there. So I took that step out, but I put it back in now. And now plug in the values. It's 4 pi. R is what? 9. 9 squared. And dr dt is what? 7. I forgot a calculator here. Clear? Here we go. 4 times 81 times 7. It is 2268 pi. Whatever that number is. This will be cubic inches per minute. Cubic, because volume is always in cube. Cubic inches per minute. And number 10, the last one from this section. We have an aircraft. It's 6 miles high. Flying in this direction. So this is 6 mile high. Passes directly over a radar. So we have a radar right here. There's the signal of the radar. It passes over that and now continues to fly. When the airplane is 10 miles away, S equals 10. This is S. When S is 10 miles, this is the radar detect that the distance S is changing at the rate of 210 miles per hour. So ds dt equals 210. That's increasing miles per hour. What is the speed of the airplane? If I call this distance, what should we call this distance? Should we call it x? What's dx dt? That's really what they're looking for. We don't care about that distance. I'm flying that plane. I need to know how long it's going to take me to get to my target. Let's say I'm flying, this is over Bradley, and I want to know when I go over George Washington Bridge here. I'm going horizontal there. I know the distance from Bradley to George Washington, direct distance. You tell me what the speed is, I'll tell you what the time is. And that's how they estimate when you're flying, guys. Estimate time of arrival. ETA, you estimate time of arrival. It's the distance divided by the speed. You divide them, that tells you when you're going to be there. So I need to find dx dt. When s equals 10, this is 6. Well, there's one equation I can think of it that will tie x and s together, because that looks like a triangle to me. So that's Pythagorean's theorem. Now, take the derivative of that with respect to time, 2s times ds dt. The derivative of x squared is what? 2x times dx dt. 6 squared is 36. What's the derivative of 36? 0. That's a constant. Plug in the values. You should be able to solve for dx dt. 2 times s is 10. ds dt is what? 210. 2 times x, I'm looking for a dx dt, but I'm missing an x here. Can we find what x is? When s is 10, what is x? We go back to this equation. S is 10. 100 minus the 36 equals x squared. What's that, 64? X will have to be 8 miles. So I can put 8 here, and now I get dx dt. (20 times 210) divided by 16. The speed of the plane is 262.5 miles per hour. (262.5 miles per hour). So if I know how far George Washington Bridge from Bradley, I can divide that distance by the speed. That'll tell me how many minutes before I get there. Okay, that was from section 3.7. Any other questions? From 3.8, 3.9, 3.5.
I'll ask you.
Go ahead.
Well, it's number 8, and I had a discrepancy on my,
Which section?
the one you're using.
3.7?
Yeah. I'm sorry to mess up your flow.
It's all right.
I forgot about I had the question. I kept getting 8 foot squared for a minute. It doesn't really matter for the answer on part B, but I got it right. Just didn't. Kept getting foot squared in there. Must have been missing something somewhere.
I don't like the problem because I got to do it in 3D. I got to graph it. And I don't like graphing.
You made a nice cutoff last time.
I don't know. I won't call it nice, but oh, what do I do with that line now? Where does it go? 3D, just visualize that. Good, better than because I can't. Now, I don't know if I can, maybe. So we adding water to this one. We keep adding water to that in 3D here. Again, you got water been added to this at the rate. First, this one has dimension of 12 feet. My picture is deceiving here. 3 feet here. The 3 looks like bigger than the 12. And what about the other side?
It's 3 feet tall as well.
3 feet this way.
And it's coming at 2 cubic feet a second.
And this is the height h. This is number 8. Part B, you said?
Yeah.
If the water is rising at the rate, the water is rising. That's dH dt. Rising at the rate 3/8 inch per minute. When h equals 2. Find dV dt. Again, I need to look at the water there and find a relationship between the volume of the water in that tank and the height. So if I look at that, the front alone, this is what I see in the front. This is 3 feet, and this height is 3 feet. And it has water this much. Well, the volume of a shape that looks like, well, let's look at the area. The volume is the area times the length. Well, we know the length is 12. So the volume is the base here times the height. What do you want to call the base? You call the distance from here to there. What do you want to call it? Z sounds like a good one to use. Z. So the volume is Z times the height. The height is this distance divided by 2. Well, that's the area times the length of that, and how deep that is. Isn't that 12 feet long, that piece? Times 12. That's just the area of this piece. The area times the length or the depth is your volume. So that ends up being the volume is 6 times Z times H. Well, we don't like Z here. So can I replace Z with H? Well, if you look now, I got two triangles, similar triangles. This is one of them. This big one. So I got two triangles. Or I can look at the whole thing actually. This is the big triangle, 3 by 3. And the little one, the water inside that. And that's H by Z. Right? You get the big triangle, which is this whole thing. The red one, that's the whole thing, that's the big one. And the little one, which is the water, which I'll color that in yellow. Can you see the yellow on the screen? So we get similar triangles. And the ratio of Z to H is the same as the base to the height. And this will be what? 3 to 3. So Z really equals H here. 3 over 3 is 1. So now instead of having Z here, I can replace that with the volume of the water there. 6 times H, which is what? 6H squared. Now take the derivative with respect to time. Derivative V is what? dV dt. 6 times 2 is what? 12H times dH dt. Now let's plug in the numbers. Let's find dV dt when H equals 2. What's 12 times 2? 24? Almost said 48. 12 times 2 is 24 times dH dt, which is what? 3 over 8. By 8, this is 1. By 8, this is 3. That's 9. And again, it's a volume. Inches?
You gotta convert it to inches.
What's the other one? Feet?
Yeah, feet and there, and then you have inches per minute there. So you gotta convert it. It's 1 over 30.
Inches per minute when H equals 2. Oh, that's in inches, yep. Cubic inches. And I'm assuming the 2 was 2 inches there when they gave us that 2. The height was 2 inches, right?
No, the rest of your thing is feet. So you have to convert your inches per minute into feet per minute.
Oh, wait a minute. That's inches, and this is the 12 is what? Feet, yep. The ratio is good there, but 12 times, well, this is actually, yeah, that creates, I forgot that part. They have inches and feet. So let's convert. This is good here. 12H. So one step here before that. That's still okay there, right? I wasn't planning on using the whole thing here. 12 times, what's h? 12, h is what? Is that feet or inches?
H is feet.
Oh, feet, yeah. H is feet, oh, wait a minute.
Yeah, it's all in feet, so you gotta convert it. You should just convert
H 2 times 2, which is 2 times 12, which is what?
24.
24. So my answer is going to be in inches cubed, and I'll convert that after. So this is when h equals 2. I didn't see the number, but on the picture they have feet here, which is really 24 inches. So 12 times 24 times 3 divided by 8, it is 108 cubic inches per, was it minute? Yeah. But they want the answer in feet, cubic feet.
But your 6 was also in feet, because that was your
My 6,
Yeah, so you should just convert the inches per minute into feet per minute. Does that make sense?
my 6, where's my 6?
Your V equals 6 times E times H. That's
Oh, that's in,
yeah, that's your depth. That's in feet still too. So you should just take your 3/8 inches a minute and convert it to 1/32 feet per minute.
I should convert everything from the beginning. I didn't see the inches in feet. You know what?
Answer is feet per minute anyways.
I know. Let me just start with this clean. Convert everything from the beginning. Make life easy. When h equals 2 feet, or let's write it 24 inches. The dimensions of this, 12 times 12, which is what? 144 inches, or 12 feet. This is 3 feet. It's okay, that's 36 inches if you want it. I don't know. That doesn't look like a 3D now.
I think you're doing it the hard way.
Now I want to make sure that the notes are all nice. I'm tired of erasing everything.
So why are you going to do like 10 conversions, but you can just convert the inches per minute?
I could convert that to feet. It makes it more fun that way. And similar triangle, that doesn't really make any difference. If you don't have to convert that, you can still stay as long as 3 feet here to 3 feet. This is, we decide to call, what was that? Z to H. So the ratio of Z to H is 3 to 3, which means H equals to Z. The volume is, I call this distance Z times the height, Z times H divided by 2 times the length of that, which is 144 inches. That's 72, not Z2, 72 times Z times H. Well, since Z is equal to H, oh, that's just V. I didn't take the derivative yet. So what's dV dt? 72 times 2, is that 144? H times dH dt. So 144, what was H? What was the height for that one when they asked for the derivative? At 2 feet? 2 feet is 24 inches. dH dt, which is what? 3/8. I got 1296 cubic inches per minute. And what do they want the answer in? Oh, they want cubic feet. No big deal. Convert
Is it cubic feet a minute?
per minute, yep.
Okay, so yeah, this is what.
Cubic inches per minute. So I need to convert the inches cubed to meter to feet cube. 1 foot has how many inches? 12. But that's a cube. That means you got to cube this, cube this, cube this, cube this. 3 of them. So divide that number by 12 cube. And you will end up with the answer dV dt equals 0.75 cubic feet per minute. So you don't just divide it by 12, it's by 12 cube because of volume. Or you could just, as I said, convert this to cubic feet or feet per minute and leave the rest in feet.
See, my problem was I wasn't
Cubing?
where you're 144.
Yep.
Right there, I didn't carry down. Oh, I'm a stickler for like my feet per minute.
Yep.
So I didn't carry down my feet to 144. Where your 144 is, which is my 6. I didn't have my whatever you call it.
Yeah, when you see a problem with units like
Yeah,
this,
that's my units.
yeah, it's really easier to switch them to one unit from the beginning. I didn't even notice that till you brought it to my attention that the units are not matching, you know? Okay, while I'm in review mode, anything from 3.8? Yes, no? 1 and 5? Number 1 and 5. Any other ones besides 1 and 5 while I switch the computer to homework 8? .8. Once I find it. Oh, that's the one I don't want to do. F of x equals x squared minus 7. And we wanted to find the root. And listen, let's start with the value of 2.8. And if you remember, that's a table. I forgot that section there. So the first try, I don't know why I didn't go to the end. The first try, I'm going to use that number. That's n. I'll just run it here. I have no idea how far we're going to go. What's f of x of n? So when x is 2 let's use x here. Let's write what x of n first. So I'm going to use the 2.8 first. Then let's do the value, see if that's an answer. Sometimes you're lucky, that number happens to be an answer. I guarantee you not here. Then I have the derivative of x of n. Then I have f of x of n over the derivative and the last one is 1 minus, or x of n minus, not 1. That's the table we have to use. We're going to start with the 2.8. Plug it into here. What's 2.8 squared minus 7? 0.84. Is that a 0? Or close to 0? No, that's not good. What is the derivative of x? Isn't that 2x? What is the derivative at 2.8? That's 2 times 2.8. 5.6. Divide this by this, put the answer here. 0.15.